Today's lesson is called Solving Rational Inequalities. And all that means is we're going to have some rational over here and then a greater than sign instead of equal. That changes the game a little bit. Fair warning, this lesson comes in two parts. The first part, I'm going to explain the plan of how we're going to solve this. Then the second part, I'm going to grab a homework question and go, how can this play out so that we get in a little bit of algebraic trouble? And I got to tell you something about algebra. Same as yesterday's lesson, where I'm like, let me tell you about the algebra here a little bit. I got some algebra to tell you about today, and you're probably not going to be happy. Yeah? So zone in. This lesson's got that other shoe to drop. At first, first half, you're like, oh, this is going to be easy. Then something happens. It's not the worst, but hang in there. If you're totally understanding it and getting bored in the first half, don't jump ahead. Stick with me, because there's some little things I got to tell you about here. Okay, we have dealt with polynomial inequalities already. Our strategy was simple. Take the polynomial and graph it. Well, I don't know. I was trying to convince you not to graph it, to chart it, and hopefully you found out this chapter that it was good advice, switching over to charts instead of relying on graphs, okay? But you could still graph it. That still works. Then we could visually see when the graph was greater or less than a certain value. Will the same strategy work here? Absolutely. Say I wanted to find out when 2x squared minus 3x minus 5 over x squared minus 3x minus 18 was greater than 0. See, 0, the first example I'm doing with a 0, so it makes it easier. First, go through the steps to graph this thing. And I'm not going to belabor these steps, because hopefully you've seen these steps, but it's a good review of the steps that I told you the other day. Find X-Intercepts. I think I called this step 1 when I taught it to you yesterday. Or sorry, step 2. But find the X-Intercepts, so I set the y value equal to 0, which means I need the numerator equal to 0. This one factored, and I got my two zeros, my two X-Intercepts there. Then find the y-intercept by subbing in x equals 0. The numerator is going to be 2 times 0 squared minus 3 times 0. Only the negative 5 survives. And the denominator, only the negative 18 survives, and the negatives cancel. Hopefully those steps are like, okay, yeah, that's fine. Because that really was at the very first part of the first lesson of this chapter. But are there any questions on finding x and y-intercepts? Okay, so I'm just going through the steps to graph again. And actually a good review sheet, if you're like, I want something that shows me all the steps to graphing. This sheet here totally gives you that all to you, because it's basically a graphing question. And then for domain issues, which yesterday when I did them first. I set the denominator equal to 0. So again, it's just factoring. And I found out that x can't equal negative 3 or 6. And then the last thing I did was find that horizontal asymptote. That's a degree comparison. Let me mention that again. Horizontal asymptote, you compare the degree of the top and the bottom. If the bottom has higher degree, it goes to y equals 0. If the top has higher degree, there's no horizontal asymptote. And when there's a tie, the tiebreaker is the coefficients there. You go ratio 2 over 1. So 2 over 1 is horizontal asymptote equals 2. At this moment, though, you might raise your hand and go, wait a minute. There's some things you did there that I don't need in this question. If I just want to know when it's greater than 0 and I'm going to chart it, I don't care about the y-intercept at all. That doesn't change my life even a little bit. I do need the x-intercepts for the chart. So let me highlight that. Yes, do need the x-intercepts to build the chart. If my only goal is to build the chart, I need the x-intercepts. And on this next page, I really don't need the horizontal asymptotes to build the chart. So I'll put a little X there going, I don't really need that to build the chart, but I do need those asymptotes. That doesn't shorten the procedure very much, but it is something to note that you don't need all that stuff if you're just trying to build a chart for this thing. Then let's walk through building a chart. This is the big version of the chart. That's not the one I've been doing in regular lessons. I've been doing a small version of this where I don't write this all out like this. You don't have to write it all out like this. It's a good reference, though. It's good to see, so you see where this is all happening. So if you're still having trouble building these charts, what you do is you make a list of all the x-intercepts, which was 5 halves and negative 1, and the vertical asymptotes, which is negative 3 and 6. Well, that's not a very good list, because that's not in the right order. You want to do them in the proper order. So lowest was -3, then -1, then 5/2, then 6. And you can see those are the numbers I use to break up the interval chart. X less than -3, between -3 and -1, between -1 and 5/2, between 5/2 and 6, and X greater than 6. This one has a lot of intervals. You know, some of the homework ones maybe have only 3 intervals. You don't have to go quite this far with it. So how does this chart work? I'll do a couple of them, okay? I hope you're getting to the point where it's like, okay, you don't need to belabor these charts, but what you do is you look into each particular interval and you go, okay, say X less than -3, I'll choose an X value of -5 to test, and you go, okay, 2 times -5 minus 5, that'd be negative, -5 plus 1, that would be negative, -5 plus 3, that's negative, -5 minus 6 is negative, and you don't have to write this all out. I was just making little notes underneath. When I did them before, remember, I was just like, a couple little notes underneath. Negative, 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 4 negatives. When those multiply together, I get positive. Okay? I'll do one more interval. Say between 2.5 and 6, say a 4. That means 2 times 4 minus 5, that would be positive. 4 plus 1 is positive. 4 plus 3 is positive. 4 minus 6 is negative. And when I multiply and divide all those together, I get negative in there. And you could answer the question right now. You'd be done. You don't need the graph. This tells you the answers. We want to know, when was this function? Oh, I've forgotten. I already forget what I was looking for. When is this function greater than 0? Right there, X less than -3. Then between -1 and 2.5, and X greater than 6. Those are the times we're looking for there. Or sorry, the intervals we're looking for there, where this thing is greater than 0. Okay? Do you have any questions about that procedure? If you're right with me and have done even some of the homework, you might be like, please tell me you did not bring me on the Thursday before Easter to show me that. You know, I could have stayed home today. That wasn't too bad. No, I told you this lesson was 2 halves. The first half, if that situation is already greater than 0, interval chart, boom. And you'll get really fast at these. Finding X-intercept, setting the numerator equal to 0, and solving, setting the denominator equal to, and solving, you'll just be zipping right along through these. So, let me say it one more time. If that's greater than 0, life's easy. Yeah? Bing, interval chart, done. You could also graph it and find the answers. See, the answers are over here. Here's the 3 sections over there, and between there and there and there. But there is no need to graph it here. You don't have to. But if you feel better about graphing it, you can go ahead. Here you do see the horizontal asymptote and the Y-intercept. But you don't need those for the interval chart. Now we're ready to answer the question. So there's the final answer. I wrote it on the other page there, but there's the technical way to write the final answer. Well, every homework question, you have to write it perfectly like that. You know, but come test time, it's like, okay, statement at the end and state the whole answer. Notice how only the last line is new to this section. If you can graph rational functions, the rational inequalities are easy. Ooh, if you can graph rational functions, the idea of rational inequalities is equal. Okay? Big algebraic moment coming up, though. So if your brain was half off and you're already thinking about Easter turkey and all that kind of stuff right now, now's the time when you want to put in there. I wrote a reminder to myself, hey, Rob, that's not good enough. That lesson's not good enough as it sits. Do one of the homework questions and show them that algebraic trick. This says, Rob, do 296 number 4D. So where's my textbook? 296 4D. Fresh page. I'll get the whole page there. And I'm going to do from your homework, green. I don't want green. Well, maybe Easter colors, right? Purple. I'll write in purple today. Page 296. Number 4D. A seemingly simple looking disaster. 7 over x minus 3. And they want 7 over x minus 3 greater than or equal to 2x over x plus 4. Okay, so a number of problems, big moments in this chapter. The number one mistake, the number one costly mistake on this upcoming test is going to happen right here. So be ready to understand what I'm talking about here. The first trouble is it's not greater than or equal to 0. If I build an interval chart now and tells me positive and negatives, that's not going to tell me about what greater than or equal to 0. So that's bad. That's not the big issue. The big issue is after yesterday, me going on and on about multiplying through by the common denominator, it will be dead tempting to multiply through by the common denominator. Your brain will be screaming, multiply through by the common denominator. So I'm going to write it down and X it out. I think you should in your notes too. I think you should do exactly what I'm going to do is go multiply by common denominator. Question mark. And I'm going to get out my red pen and I'm going to put a big circle around that. And the slash through going, no, cannot do that. You might be mad at me. You're like, you made such a big deal about that yesterday that I automatically want to do that now. And now you're saying I can't do it here. So let me explain why we can't do it. If I multiply through by x minus 3, even one of the denominators, what we have to realize is if x minus 3 happens to be negative, I'd have to switch the direction of this inequality. And I won't know if x minus 3 is negative or not. You're like, oh, I could figure out when x minus 3 is negative. Maybe it'd be okay. If I could follow along. And that's true, you could do that. But you're also multiplying through by x plus 4. So then you got to figure out when is x minus 3 negative and x minus plus 4 negative. Because that on those times I'll have to do one question where I reverse the inequality. When x minus 3 and x plus 4 aren't negative, then I don't reverse the inequality. I got to do a separate question. So you have to do two different questions. Oh, it's way worse. If they're both negative, then you're actually multiplying through by a positive, and then you don't have to switch the direction. This is a disaster as far as keeping track of everything that you have to do. And you could do it. You could survive. And I'm telling you, this question would probably take about triple the length it has to if I tried to manage all those things. So the inequality makes it so you cannot multiply through by variables. There's a perfect sentence. Let me write that sentence down. The inequality makes it so we should not multiply by variables. I think when I said it out loud, I said could not, cannot. It's not true. You can. But you've got a lot of work to do to keep track of when those variables are positive and when they're negative. So we need a different algebraic move for these. And by the way, if when I finish you're like, oh, you've messed me up. Now I've got two different moves for two different types of questions. If you need only one move, this is the move. This is the move to do yesterday and today. It works both times. So if you can't be bothered to memorize both methods, not can't be bothered. If that's not the way your brain works, if you want only one method, then this is the way to go. Instead of multiplying through to clear out these fractions, what I'm going to do is just bring it over. This is a very happy step. And what I mean by it's a very happy step is it's fairly easy to do, to bring that fraction over there, to bring that rational function over, and now it's greater than or equal to 0. You know, that's another one of those 0 happy, I'll write it in there. See, I'm so happy to see the 0 over there. Happy 0. Because now I can build an interval chart. Oh, he's got a little bit of hair there. There you go. He's a very happy 0. But there's a problem that just happened, is that this isn't a single rational function. I can't do anything with it when it's two different pieces like that. I'm going to have to put these two fractions together. Oh, and it gets worse. How do I subtract fractions? What do you need to be able to subtract fractions? Yeah, so yesterday I sort of glossed over common denominator and said, oh, we don't need a common denominator. And I was totally lying to convince you about one type of algebra, which is, hey, we can multiply, with equations, we can just multiply through and we won't have to do common denominator. With inequalities, we're stuck with it. We're stuck with common denominator. So here's my steps to common denominator. What I do is I write down the 7 over x minus 3, and then I multiply top and bottom by that other denominator, which is x plus 4. So top by x plus 4, bottom by x plus 4. And then this one, instead of x plus 4 top and bottom, I'm going to multiply by x minus 3 top and bottom. I find that the easiest way to manage the algebra. Ooh, I meant to do that in red. Un momento. red. And then this is x minus 3 over x minus 3. You can shorten this procedure down, by the way, when you're doing it, and write less. But because I'm teaching it, I'm going to show every single little step. And that's greater than or equal to 0. That is not the same as multiplying both sides by x plus 4 and x minus 3. What I've actually multiplied this thing by is the number 1. X plus 4 over x plus 4 has value 1. So that's a different move completely than what I did yesterday. Even though it sort of feels the same. It seems like I'm multiplying things. But here I'm multiplying both of those terms by 1. And then what I do is I do no simplification in the next step. I go like this. I go, oh, 7 bracket x plus 4 over x minus 3 x plus 4. What I really like about that step is I can look back and forth and see if I've made a mistake. See, I can sort of see that the x plus 4, don't cancel them. Like if you cancel them, you're going back to what you had before. But you can see that I still got the right thing. 7 over x minus 3, x plus 4, and x plus 4 on the top. And this one's 2 bracket x minus 3 over x plus 4, x minus 3. Whoops. And then I bring them together. I go, okay, so the numerator is 7 bracket x plus 4 minus 2 bracket x minus 3 over x minus 3, x plus 4. And that's all greater than or equal to 0. And I'm very happy at this moment because now it's all one fraction, all one rational function that I can work with. And I've got a little tidying up to do. I'll show all the steps here. This is 7x plus 28. This is negative 2x plus 6. And then x minus 3, x plus 4. And maybe there's a question looming. I multiplied out the numerator, but I didn't multiply out the denominator. And that's a little mysterious why I didn't do that. But I'm going to finish this off and then pause to talk about why I multiplied out the numerator, but I didn't multiply out the denominator. And I'm extremely happy right there. Extremely happy because it's all one rational, greater than or equal to 0. Now I can just do what I did in the opening example. Everything's all set up to do. But it had to be common denominator to get you there. It couldn't be multiplied through to get you there. It's very mysterious why I multiplied out the brackets in the numerator, but I didn't do it in the denominator. And this is an idea that permeates all the way through calculus, AP calculus. It happens again and again. And the reason it happens is because the denominator is already factored. Don't multiply out things that are factored. It's already beautifully x minus 3, x plus 4. The numerator is not factored. It's actually two separate set of brackets with subtraction between them, not multiply between them. And that's why the numerator gets multiplied out, because it's not factored. It has to be simplified first, then I can factor it. And I'm going to factor it weirdly. Maybe you haven't seen factoring like this before. You don't have to do this. But if it's a common factor that doesn't make too much of a mess, it sort of helps my thinking. Again, not a necessary step to common factor out of 5 and make that 6.8. But I think when I go to do the chart, you'll see why I did it, why it's sort of a handy move. Okay. All right, so these things have two distinct parts. One, use common denominator to get them all the way over to one side, and then a 0 on the other side. Then 2, build the chart. And for the chart, I only need 2 types of things. And the way I factored here, I can get them easily. I'm going to write them right here. All I need for my chart is X-intercepts, which here are easily picked off. X equals negative 6.8. Do you see why I factored that like that? Made it a little easier to pick it off. Not necessary. Don't have to do that, but it was nice. And then I need the vertical asymptotes. And let me just say that out loud again, because some of you with the charts, if you're not quite caught up on old homework, if you're not quite caught in homework, you might not know what to use for the charts. There's the stuff I need for charts. When you want to build the chart, the information you need is X-intercepts and vertical asymptotes. Those are the 2 things you need to build the chart. Questions there before I jump ahead to the chart? More time? I don't want to rush you. More time? I'm in the home stretch already. I'm going to do an interval chart, and then this lesson wraps up then. And then it's really about you in practice. Like watching me do 1,000 of them does not help you. You need to get in there and hammer away at these things to get that expertise down. Okay, so if I've forgotten already, it was X. I think the lowest one was negative 6.8. Then the next one is negative 4. Then 3. And then X greater than 3. Am I remembering those right? I better flip back to double check. Managing my windows here. Negative 6.8, negative 4, negative 3. That's what my brain tells me. This is covering this now. Negative 6.8, negative 4, and positive 3. Yes, that's right. Negative 6.8, negative 4, negative 3. Okay. And positive 3. Okay. And then, like this. Now I need that whole function. It was 5 bracket x plus 6.8. And the denominator was x minus 3, x plus 4. And this building of charts thing, I hope it's coming easy for you now. Just going to tidy that up a little bit. So x less than negative 6.8, say like negative 10. That means the 5 is going to be positive. That's going to be negative, negative, and positive. As I put those in there, that's positive, that's negative, that's negative. Oh, that last one's negative. I knew that didn't feel right. Negative 10 plus 4 is negative. So it's negative in this section of the graph. Or the chart. I'm not going to build the graph, the chart. Between negative 6.8 and negative 4, say negative 5. The 5 is still positive. When I add 6.8, now I get positive. And on the bottom, still negative, negative. So this part is positive in that section. Between negative 4 and 3, 0. I love subbing in 0. 0 is easy to handle. Negative in that section. And then the last section often is easy as well because everything this time comes out to be positive, and that section is positive. And I'm ready to write the answer. Don't let this confuse you though, because it's not, I used my chart to find out when this function was greater than or equal to 0. So what I really wanted was this. So 7 over x plus 3 will be greater than 2 over x plus 4 when this function is greater than or equal to 0. So my conclusion really should go back to the original and say, okay, 7 over x plus 3 is greater than or equal to 2 over x plus 4 when, what do we got? Negative 6.8 less than or equal to x less than or equal to negative 4, and when x is greater than or equal to 3. Because they wanted greater than or equal to, and we learned in chapter 4, need your brain back for another 30 seconds. Don't leave for Easter yet. We learned in chapter 4 when that was greater than or equal to, then our answers would be less than or equal to, greater than. You'd include that equal sign all the way along the way. So you do all that, you hand in your test, it's beautiful, you even graphed it to check, and you get 5.5 out of 6, and you're angry because something little has gone wrong. Not wrong. I've neglected one little thing that I need to mention to you that happens every once in a while. This says negative 6.8 less than or equal to x less than or equal to negative 4. And it says x greater than or equal to 3. What's wrong with that? We will do the awkward pause so that you get full attention here. Restrictions. Yeah, I kept coming back to restrictions. Lots of times when I did restrictions, it was like, it's never matters. You look back at the restriction and go, it doesn't matter. Why am I still looking back for these? Because every once in a while, like this one, you look back and go, let's imagine you went to your boss and said, okay, negative 6.8 less than or equal to x less than or equal to negative 4. That's the answer. And they look at it and go, but I thought you said back here that x can't equal negative 4. You're like, oh, yes. Okay, I'll fix it. Here I come. X less than negative 4, like that. And if you're like, really, Mr. Todd? And my answer is, yeah, really. It's a problem. You got to watch out for these little things. And what was the other thing? X greater than or equal to 3? X can't equal 3. So it can't be greater than or equal to 3. So compare your answers carefully as you're doing these so you don't miss catching those things. AP moment coming up. In calculus, we do a modification of the charts because this comes back to bite us again and again. And when we draw the charts, and I encourage you to do it, whenever it's an asymptote, instead of drawing a straight line down there, we actually, let me get a white pen out. Oh, maybe my eraser will do here, a little tiny eraser. When there's an asymptote there, like there is at -4, we actually draw on in our chart, we draw that as an asymptote. Just to remind ourselves, hey, careful now, that thing's an asymptote right there. So this is a cool calculus trick to avoid running into these problems and reminding ourselves that these two things were asymptotes. And so then when you go to the less than or equal to or greater than or equal to, you know not to include those things along the way. So something you might want to try. You don't have to do that, but it's a nice habit to get into, that asymptotes get put on the chart as these dotted lines instead of solid lines to remind you that those things don't exist there. Whew. Any questions there? This needs a set of instructions. Yeah? Let's just take one more minute here and make a set of instruction for these things. Rational inequalities. And again, this one little moment in rational inequalities might be that magic thing you write in your test. Some of you got very good at that. I hand you the test and immediately you write something at the top to go, just don't forget this. Please don't let me be the one that forgets this. And I'll change I'll make it in big capitals when I do it here. 1. Move everything to one side, leaving a 0 on the other. That is not a new idea. We've been doing that a lot in the last couple of chapters, making sure we get a 0 on one side. 2. This is the big one. Use common denominator to combine the pieces. And if you're not going to copy down anything else, this thought bubble's the big thing. Don't multiply through by the common denominator. And I know what just happened, that yesterday I pounded away on that idea. We want to multiply through by the common denominator, but we cannot do it for inequalities. It'll make a big mess. 3. Use X-Intercepts and vertical asymptotes to build a plus-minus chart. Notice some of those steps aren't always needed. In the very first one I did, it was already on one side greater than 0. So when there's already a 0 on one side, you can jump right to the chart. You're on your way already. Do you have any questions on that procedure? Anything at all? Do you need more time for your instructions here? Yeah, more time there.